Geotrig Lesson 13, intersecting secants is the first one. So first thing before we talk about what that's going to happen with the secants, probably let's do what is a secant. What is a secant?
A line that intersects a circle.
Right, it's a line that intersects a circle at 2 points. So it's basically, look below there on the circle, we have two secants crossing inside a circle. Those are both secants because they touch the circle at two different spots. Yep, it's at there. That's all right. Line that intersects at 2 points.
Are you recording?
Yes, I am. So let's look at that starred part there. And it says, if two secants intersect inside a circle, the measures of the angles formed equal 1/2 the sum of the measures of the intercepted arcs. Sometimes reading something like that, it's not easy to see or to visualize. So what I did was I drew a very generic diagram here with a circle with two secants, and I labeled the angle inside. Now, it's very important, guys, that you can recognize that this angle or that point of intersection does not have to be in the middle. I kind of hopefully drew it slightly off middle or off center so that you guys can see that. But we know that those two angles there are the same because they are vertical angles. That's good. I'm glad you guys are seeing that. And I have to name one arc 1, arc 2. In this problem, it doesn't matter which arc you call arc 1 or arc 2. Later on, it's going to matter in a way. So what happens if you want to find the angle inside, one of those vertical angles with x there, all you have to do is take arc 1, arc 2, add it together, divide by 2, and you have it. It's not that bad, is it? The biggest problem about this is to remember which one goes where. And again, these ones don't have a problem with that. So when we get to our next couple examples, when we start to change that formula up a little bit. Okay, now we're going to start to move things around. We're going to take that point of intersection and we're going to pull it to the outside of the circle. And we're going to start to move them so it all of a sudden becomes not two secants, maybe a secant and a tangent. Now, at this point, it's going to make a difference which one you call arc 1 and arc 2. Okay? Because, and I'm going to get the formula next, I'll let you guys get this down. It's going to make a difference because it's always going to be from one arc subtracting the other arc. And so, what I'm showing here, and I got one more example here, we got two secants that meet outside. You have a secant and a tangent. Remember, a tangent touches the circle at exactly 1 point. And the cool thing about a tangent line is that a radius to that secant point, or that tangent point, will form a right angle. So the tangent line is this one, and then our secant's the other one. They meet on the outside of a circle. Still follows the same exact process. I'm going to turn the page. And the third case, which is going to be slightly different, and actually, I just realized that that's going to be wrong. So do not worry about that. Let me see if I can fix that. Okay, we got her fixed now. Guys, this one, the two lines cross on the outside of the circle, but this one's made up of two tangent lines. So that means that it's just touching once here and once over here. Okay? Now, we also know that when we have two tangent lines touching a circle, what about these two lengths here? What about this length and that length? They will be the same. So don't forget that. So the formula that we're talking about for all those last 3 problems is right here. They were going to be, when they cross on the outside, arc 2 minus arc 1 divided by 2. No, this would be for the last 3. The first equation only was for that first example. So, anytime they cross inside, you add, divide. Anytime they cross on the outside, you subtract, you divide. Now, what happens if you did this and you accidentally came out to a negative answer? What was most likely what you did? You subtracted the small one, or you did the order of small minus the large. So you always got to think of, when you're doing your subtraction, do the big arc minus the little arc. So even if you don't want to call them arc 1 and arc 2, you can go big arc, little arc. Okay? So this isn't too bad, right? So the next thing, we already did this product of chords, guys. Remember, chords are not lines that cross through the circle. Chords were, they terminated on ends of the circle, right? At the edges. But remember, when 2 chords crossed, then you can take their pieces, right? Multiply them together, and they're equal to the other chord's pieces multiplied together. So in this case, A times B equals C times D. Makes sense? We've already done that. But what happens if I do products of secants and tangent segments? So this time, we're doing the first example there. Here is just 2 secants. They cross inside, versus the second one has a tangent line. So here's a really cool thing that someone found out, was that if I take the pieces, so those secants end up at a terminal point on the outside, they found that if I take the outside segment and multiply it to the whole segment, it's the same as the outside segment to the full segment of the other secant. So A times A plus B is equal to C times C plus D. I have examples of all of these later on here. Okay? The difference between the secant one and the one that has the tangent segments is the fact that there is no inside part here, right? So what they do, if you look at the formula, they end up calling it C squared. So you still get the A times A plus B for the secant that runs through, but the tangent line ends up being C squared. So what's going to happen is they're going to give you a variable in one of those spots, and you just have to solve for it. So it shouldn't be too bad. So we had a good question. Because it ended up being C squared, could the variable be in that spot? So we end up having an x squared. And when we have an x squared, we end up having a quadratic. And a quadratic has up to how many solutions? 2. So what should you do with your answers? Check them. Because what would you not have for a line segment? A negative. So be very careful. I think I put an example of something like that on here, though. All right, first example. Now, I changed it up a little bit. I didn't want to make it too easy for us. I gave you one arc being 30 degrees, another arc being 40 degrees, but the angle is what? Half x. So I'm just going to use simple substitution here. Wait, what's the formula for this one?
A times
X equals?
A times B.
No, we're not doing line segments.
Arc 1 plus arc 2 divided by 2.
Arc 1 plus arc 2 all over 2. Which one are we calling arc 1? 30 plus 40 divided by 2. That would equal what? 70 over 2, which is 35. Here's the problem, guys. What did we just solve for? Did we really solve for x? In our particular problem, x is actually half of x. So this x here should say 1/2 x. I'll set that equal to my 35. Multiply it by 2. Because the angle up here is a half. So I got to get x by itself, right? So now that's why we multiply by 2. So x is equal to 70. That's the tricky part they're going to do. They're not just going to give you the formula and say, here's some numbers to solve for it. They're going to put things like 2x and 3x. So you have to solve for that position and then say, hey, wait a minute. It wasn't x or a or b. It was 2 of those. So then you have to continuously solve it or get to that next step. Next, we have them cross on the outside. So obviously we use a little slightly different formula, correct? The new formula is
1/2
x equals, or wait, is it x now? Look at our problem.
2x
It's actually 2x. I'm just going to put 2x in right away.
equals arc 2 minus
A2 minus A1 over 2. I'm just going to use big A's for arcs. Is that okay for now? So, what's the first arc? 8. Where are you getting 8? What's our big arc?
75.
75. Minus?
15.
Over? 2. 2x equals 60 over 2. 2x equals 30, or dividing by 2, x equals 15. That's it.
That's it for the day, right?
No, not for the day. We got a couple more examples to do.
We only have 3 minutes.
Oh,
Can you keep this up?
here we go.
Never mind.
Same formula, yes? So, in this case, x equals a2 minus a1 all over 2. What goes in x? 20. Now it gives us the angle, and our big arc is 80 minus 3x all over 2. And then you just have to solve the equation. You guys want me to leave this for you guys to do, and then we go into the next example? Keep going?
Yes.
As in this problem?
No. Yes.
Multiply by 2 to get? You guys got to help me out. 40. 80 minus 3x.
Wait, we times that by 2, don't we? Wait, why is 20x? Shouldn't 3x be x?
No.
Because it's not arc.
Yeah, it's 3x is in the arc. 20 is the angle.
Okay. That was different.
Okay, so I'm going to subtract 80 to get negative 40 equals negative 3x. Divide by negative 3. 2 negatives make a... And so x doesn't turn out to be a nice number, so I'm going to leave it as 40 over 3. Okay? Next. Chords. I'll end on this one because the next problem after this, which is on here, follows the same rule. What's this rule? A times
A times B equals C.
A plus B equals C times C plus D. Now remember, this is a formula. Don't get it mixed up with the D's that are already there. They go in certain positions, that's all. So the first one is 3 times D plus 3. I like to put my variable first. Equals D times D plus 3 again, isn't it? Distribute.
Hey, what's 3 times 3?
3D plus 9.
3D plus 3 equals
D squared.
Did you do it again?
D squared
He did a
plus 3D. I have a quadratic, guys. I have to bring everything to one side. I think I'm going to keep the quadratic positive, right? So I'm going to subtract 3D and subtract 9. What happens to the 3Ds? Both sides. So 0 equals D squared minus 9. That's squared. You could subtract 9 from, add 9 to both sides. So 9 equals D squared. Square root. Plus or minus 3 equals D, but it can't be what? Can't be a negative. So 3D equals 3 is the only answer. Homework is on page 106, 4 through 7. Have a great day.